number 2, they say find the value of the constants a, b, such that this function is continuous everywhere. So a couple things we need to check for are any of these function pieces discontinuous at all, regardless of like where they're at here. Well, this one's discontinuous at x equals 2, but it's not defined for x equals 2, so we don't need to worry about that. This is a polynomial. It's always continuous. This is also a polynomial, more like a linear function, so that is always continuous as well. Now, the main concern with problems like these is checking if the function is continuous for its break values, like where it is broken up, right? So x equals 2, for example, and then x equals 3 for the second and third parts. So we need to find the a and b such that this function will be continuous at 2 and at 3. So kind of the shortcut, I suppose, is just like setting the first part where it breaks right before 2, basically setting it equal to the second part, the other side of where it's broken at x equals 2. The idea is this represents the limit of f of x as x approaches 2 from the left. This right side represents the limit of f of x as x approaches 2 from the right. And so you want the limits from the left and right to be equal. And so that's why we set these two equal to each other. And the goal is, I guess, just to solve for a and b. But in order to do so, we need to plug in 2 for, all the x's here, because this was the, break point for x equals 2, right? So let's plug in 2, and let's see what happens. First of all, we have a 0 situation going on, so maybe we need to factor first before we plug in 2. So let's factor up top. We get x plus 2, x minus 2, x minus 2. Let's cancel those. Now we can probably plug in the 2. So I'm going to just go ahead and plug in 2 to the left side and get 4 equals. Now let's plug in 2. We get a times 4 minus 2b plus 3. So what this gives us is 1 equals 4a minus 2b. This is just a single equation relating a and b, and this is from using x equals 2. So now let's set up the equation for x equals 3, where we will set the second part equal to the third part, because that is where the function is broken up across x equals 3, or around x equals 3. So we have 3 squared, so I'll go 9a minus 3b plus 3 is equal to 2x, so 6 minus a plus b. So once again, we have an equation relating a and b. Let's simplify it a little bit. We will add a over, so we'll have 10a, and then subtract b, so minus 4b, all equals 3. So we have 2 equations relating a and b, and now we want to use those to solve for a and b. So what could we do? A couple different options. We could use substitution. How do I want to do it? I got a clever one. It's going to be stupid, but we'll do 1 minus 4a equals negative 2b, right? Now let's double everything. 2 minus 8a equals negative 4b. And now we have something that we can plug in place of this negative 4b. So 10a plus 2 minus 8a. Do you see what happened? I replaced the minus 4b with 2 minus 8a. And this is all equal to 3. Yeah. So now we can solve for a. We can drop their parentheses. 10 minus 8 is 2. Subtract the 2. A is equal to 1/2. Now we solve for b by plugging it into any equation. Let's do this one here. 2 minus 8 times 1/2, so 2 minus 4 equals negative 4b. That means negative 2 is equal to negative 4b. That means 2 over 4 is 1/2. And b is equal to 1/2 as well. So I believe a and b are both equal to 1/2 if I did all my calculations correctly.